Okay, so today is May 17th. We're reviewing radicals and exponential functions. So the first one says the population of a town is currently 1,500 people. It's expected to triple every 4 years. How many people are living in the town after 20 years? I don't expect you to write this all down because we don't have time, but I do want you to do the math with me, okay? So how do we do this problem? Well, ultimately, we want to predict how many people after 20 years. So to set up a problem like this, you have to remember this. The first number represents the initial amount. In this problem, the initial population is 1,500. The next number that you generally find in parentheses represents the growth rate. Remember, anything over 1, we're talking about exponential growth. Anything below 1 would be, between 0 and 1 would be exponential decay. So in this case, it's tripling, so I'm going to put a 3 into this position. This is the prediction of the population after X number of years. And how often does it triple? It triples every 4 years. So although it doesn't say to create a formula that models this information, that's going to be necessary to answer this. So the next thing is, I see a common mistake in students that if they are able to get to this point, when they plug in 20, they go from left to right to plug it into your calculator, and that won't work because you have to use PEMDAS. And PEMDAS says first take care of exponents before you multiply. So let's go 3 to the 20 divided by 4. I'm using 20 because they ask us after 20 years. So 20 divided by 4 is 5, so 3 to the 5th. Now take it times the 1,500 out front. There is our answer. Ms. Shipley, would you help me? And I will call them back if they need me, okay? When I'm done. Number 2. So number 2 is asking us to solve for x. And in this case, there is a fast way. He does not come in until 12:25. So we are solving for x in this situation, and there's a fast way and a slow way. So remember, your test is multiple choice. So when I say cheat, I don't mean turn to your partner and look at their paper. What I mean is there's a faster way of doing stuff that sometimes you don't even need to understand like the difficult math behind it. Here's an example. So in this case, I can try -6. -6 plus 31 is 25. The square root of 25 is 5. -6 plus 1 is -5. Because 5 does not equal -5, the answer cannot be the second option or the fourth option because they both contain a -5. So now I'm going to try +5. If +5 works, I'm done. That's my answer. But what if +5 doesn't work? Then the answer is no solution. Okay, here we go. 5. 5 plus 31 is 36. Square root of 36 is 6. 5 plus 1 is 6. That's your answer. This next one is an example where you can use the cheating method, where you could take each option one by one, substitute in for x, do the math, then raise it to this exponent and find out which one equals 16. Because this is my 4th time doing this today, and in my previous hours I showed how you could do it the mathematical way or the cheating way, I'll tell you it is much shorter for this particular problem to do it the mathematical way. So if I want to get rid of this fraction, that's an exponent, I'm going to raise both sides to the reciprocal, which happens to be 3/2. Remember, when we say it cancels out, it really turns into the number 1. Now on your calculator, this is a common mistake. If you could all take 16 and raise it to, when you're going to raise it to a number, and if that number is a fraction, you have to keep it in parentheses. Otherwise, you'll have the wrong answer. So 16 raised to the 3/2 power is an answer of 64. I'm going to subtract 10 from the opposite side, divide both sides by -3, and I get an answer of -18. I don't want to confuse you. If you forgot how to do the math, could you one by one plug in a number, take it to the 2/3 power and see if it equals 16? Sure you could, okay? But you do have a limited amount of time that may take a little bit longer to do. The amount of money in a bank account can be expressed by the exponential equation where A equals this amount. A is the amount of dollars in the bank after T years. About how many years will it take for the amount in the count to be more than 900? Well, let's first figure out when it equals 900, and then we know any time past that point will be more than 900. So let's take this amount, and let's set it equal to 900. We're going to get an answer for t at the end. That's when it equals 900. We know any point after that will be greater than 900. So to solve this, I'm going to divide both sides by 300. 900 divided by 300 is 3. And the reason you learned logarithms this year is because in a situation like this where you're solving for a variable that's in an exponent position, there's no way to do it unless you have a log. So logarithms allow us to solve for a variable in an exponent. Here's what you do. We want to get rid of this number, so I do log of 1.005 to both sides. I go back and write what was already there. On the right-hand side, log of this number and the number behind it cancel, and I bring down what was in the exponent position. How do you plug this into your calculator? Okay, we start by doing log of the back number. So in this case, can everybody practice log of 3, enter, divided by the log of the base, which is 1.005, enter. That's what's on the left-hand side. But in order to solve this, we still have to isolate the t. So I'm going to divide both sides by 12. So a little after 18 years is when your amount in the bank has now hit $900. The question here is, when will it surpass 900? So at the very beginning of 18 years, has it passed 900? No, it's a little bit into year 18. So at the start of year 19, have we now passed up 900? Yes. Do second plus 712, please. As a quick reminder, when you have the same base and you're multiplying, you get to add the exponents. So on my calculator in just a moment, I'm going to add negative 11 fifths plus 7 fifths plus, and when I rewrite this as a rational exponent, it's not 3, it is 1/3. Now on the bottom, what number is hiding here? It is a 2. So this is written as 1/2. Okay, so here's my top and here's my bottom. Again, same base and multiplying, we're going to add the exponents. So please do this with me. We have negative 11 fifteenths plus 7 fifths plus 1/3. And normally I would tell you to put it back into a fraction, but in this case it just happens to be a whole number. When you have the exact same base and you are dividing, you are going to subtract the exponents. 1 subtract 1/2 is 1/2. Correct answer is your first option. I believe personally that number 6 happens to be a problem where you learn a formula, and if you don't use it, it's something you're going to forget, like most things. So let's write down this formula. I'll explain what it can be used for in just a second. This formula will add up the first nth terms, like the first 3 terms, the first 8 terms in this case, the first 10 terms of a geometric series. So you need 3 things in order to add them up. First is you need to know how many terms we have to add up. In this case it's 8, so wherever I see an n, I'm going to put an 8. Then you need to know what is the first number in this series. It happens to be a 6. And this last part is your rate. That means how do you go from one number to the next? Now if I gave you something like this, that would be pretty easy. Students are going to say, oh, you multiply by 2, right? Not hard. Well, how did you get that? You get that number by taking the second divided by the first. So 12 divided by 6 is 2, just like 24 divided by 12 is 2 as well. But that's not the problem we actually have. Yep, thank you. This is the problem we have. So to do that, let's do the same action. We're going to take the second number and always divide it by the first. And that tells us the rate. So the rate is 0.3. That means to go from this number to this number, I'm multiplying by 0.3. Multiplying by 0.3, multiplying by 0.3. So in this position, I'm going to put a 0.3. And even when students remember this formula and they can set it up, so often they make a small mistake when plugging it in. So please practice plugging this in with me. We're going to start in the numerator inside the fraction. 1 subtract 0.8 or 0.3 raised to the 8th. Once you get an answer, or once you plug it in, please get an answer by pressing enter. Now we are going to divide it, and this is where the mistake generally happens. We can hit divide, and we have to use parentheses. 1 subtract 0.3, end parenthesis. Get an answer. So I've taken care of the inside here. Now I'm going to type it times the initial number, which is 6, and our correct answer is the last option. Okay, you ready? I'm going to time you. The only thing I want you to do is I just want you to see, can you plug this in on your own and get that same number? Because that will be essential for us to do this next problem. You have 10 seconds just on your own. Practice with the calculator. Go. 10. Does anybody have questions about number 6? Okay, number 7. Frankie, thank you for volunteering. Frankie puts his name into some type of a drawing, and there's thousands of people, okay? And he happens to win it. And this is what the financial deal is. It says that the very first day, a company is going to send him $800. And he'll continue to receive a payment every single day, and it's going to be worth 55% of the previous day's earning. And that will continue until he's dropped below $1. So let's first just see, what does this look like? So on the very first day, he gets a check in the mail. Yay, Frankie. He didn't have to do any work for this. He just put his name into a hat. It was drawn. What does he make the very first day? Okay, so let's write that down. He makes $800. Now the second day, he only makes 55% of that. So let's take 800 times 55. So the second day is already down to 440, just so we can see what this looks like. And the third day, he's down to 242. And it'll continue with that pattern of being worth the next day's amount is worth only 55% of the previous day. But the kicker is, when will he not get another payment? Look at the problem. When will he not receive another payment? When it's below $1. So here we go. First thing, just put your calculator down and watch. I'm sure you have learned this, but maybe you've forgotten. If you do something on your calculator twice, back to back, your calculator recognizes a pattern. And it'll continue that pattern as long as you press enter. So just watch. Okay, ready? I'm going to count because the question says, what day is the first day that Frankie does not receive a payment? That means because the payment would be under $1. So if there's day 1, day 2, day 3, and because I've done it twice, back to back, day 4, 5, 6, 7, 8, 9, 10, 11. Is he still getting payment so far? 12, is he still getting a payment? But watch, on day 13, does he get a payment? No, because it's below $1, right? So the first 12 days he gets a payment. On what day does he not receive a payment? It's day 13. So I can cancel out the middle 2. The second part of this says, how much in total did Frankie earn? So you're going to write this down with me. We know he received payments for the first 12 days. The 13th day doesn't count because he did not receive a payment on that day. The first amount he received, your A sub 1 is 800. And what is the factor that allows us to go from one day to the next? What do we multiply by? 0.55. Again, how many days did he receive payments? Okay, so on your own, plug this in and then decide, is it the first or last option? Please don't say it out loud. Before you leave. Okay, the correct answer is option A. Can you raise your hand if you're able to get that? It just tells me if you understand the calculator operation part. Okay, we're going to go on to the next one. Now this next one, which is number 8, to me, it's very similar to number 2 and 3, which means sometimes it's faster to do a mathematical way, sometimes it's faster to cheat. Again, cheating does not mean looking at your partner's answer. Okay, so here we go. There has been a fire in a forest, and a conservationist is going to determine how many rare types of trees exist after this fire. So after the fire in year 1, there happens to be 2 trees existing that are rare. Then after year 2, there's 6, year 3, and year 4. Which expression, if this trend continues, which expression can be used to find the number of trees after n years? So please write this down for me. We have 2, 6, 18, and 54. I'm going to explain to you in both ways. I'm going to explain to you in the way that's like, crap, I forgot how to do this. And then I'm also going to go back and we're going to explain how mathematically can we get the answer. So in year 1, there's 2 trees. Again, in year 2 and 6 and so on. That means when I plug in a 1, I want to get an answer of 2. Let's just take a second here. Turn to your partner. What is that answer? That's not 4 degrees, 4 to the 0 power. Is the answer 0 or is it 1? Ooh, you guys aren't looking too confident. 0 or 1? It is 1. Any number to the 0 power is? Okay, we had trouble with that earlier today. Here we go. I'm plugging in 1. I'm plugging in 1 for n. 1 minus 1 is 0. N to the 0 power is? 1 times 3 is 3. Is that answer 3? No. 1 minus 1 is 0. 0 times 3 is 0, not 2. 1 minus 1 is 0. 3 to the 0 is 1. 1 times 2 is 2. It could be that answer. 1 minus 1 is 0. 3 times 0 is 0. 0 plus 2 is 2. So now I have been able to eliminate the first 2, and I'm down to the last 2. Let's plug in 2. I want an answer of 6. 2 minus 1 is 1. 3 to the first power is 3. 3 times 2 is 6. Great. Plugging in 2. 2 minus 1 is 1. 1 times 3 is 3. 3 plus 2 is 5, not 6. Okay? So that's how you can get it without forgetting if you forgot how to create an equation modeling this data. Now, if you remember, then here is your hint. How many trees do we start with? That's your initial amount. What is the rate that we're going up from one number to the next? Times 3, and this is always an n minus 1. Same thing. Okay? Coming down here, so we're going to do 2 parts. Transformations. Remember, if you have a number out front, that's being multiplied, if that number is between 0 and 1, we say it is vertically compressed by a factor of whatever the number is. But what if this number happens to be like a 3? Then we say it is vertically stretched by a factor of, in this case, 3. So that's just a quick reminder. Moving on to number 10. We have a parent function of f of x equals the square root of x, and then we're given this transformation. We want to see which one is it. So I can see a number out front, so we are going to vertically stretch by a factor of 4. Let's see what we can eliminate. Vertically stretch, factor of 4. Compress, no. Compress, no. I'm down to 2 options. Inside, remember, we do the opposite, so we are going to translate this to the right. Translate to the right, great. Translate to the left, no. Correct answer is our first one. As a reminder, we are also shifting up 2. But let's talk to your partner really quick. What if I put a negative in front of the 4? What else would you have to add to this? Reflect it across the x-axis. We're going to come back to 11 after we do 12 and 13. 12 and 13 is just applying some math. So when you find the inverse of a function, there's two things you have to do. First thing you have to do is switch the x and y. And many students say, but I don't see an y. What is y equivalent to in this function? Okay, so switch the x and y, and then we're going to isolate the y. So x equals, and I'm going to put this already into a rational exponent, just the way I like to work with it. So I switch the x and y, that's all I've done. Now I'm going to isolate the y, so let's get rid of the 2 by subtracting it to the opposite side. Now I need to remove the 1/2. So to remove the 1/2, we're going to raise both sides to the reciprocal of 1/2, which is 2 over 1, also known as just 2. When you do that, and we often say to cancel out, again, what do they really turn into? A 1. I'm going to add 3 to the opposite side. And last step will be to divide by 2. This option can be found in the last option, x minus 2 squared plus 3 divided by 2. You have not worked with logs in 2.5 months, so you may have forgotten how to do 13 and 14. How do we find the inverse? Again, let's switch the x and y. And now to solve for y, let's first eliminate the 2. It's being multiplied, so opposite of multiplying is dividing. And I'm guessing this is where a lot of students are going to get stuck. What do we do next? So the inverse operation to eliminate the log base 3 is to look at this base, which happens to be 3, and now make this the base and this the exponent. Whatever you do to one side, you must do it to the other side. We do that so that the 3 and the log base 3 cancel, bless you. Now I bring down the y, and this is the answer. When you look at your choices, though, it's not an obvious choice. What number is hiding in front of the x right here? A 1. Remember, 1/2 is the same as 0.5, which makes the third option the correct answer. Before we do 11, we are going to do 14. With your partner, I'm going to give you 1 minute. After 30 seconds, I will start on this problem. Ready? Begin. Okay, let's talk about some inverses here. If we have an inverse, keep in mind that this is the line y equals x. And let's give you a linear line. Let's say I have the line starts at +1 and it goes up 2 and over 3. 1, 2, 1, 2, 3. Y equals 2/3 x plus 1. Now if I draw the inverse of this, it looks like this. It's going to reflect across this line. So I'm just looking here, so it's like right about there, and all the way down. Now how can we find that? I'm going to take this and find the inverse quick. So this would be x equals 2/3 y plus 1. Subtract the 1 to the opposite side. Now how do we get rid of a fraction that's in front? Multiply by the reciprocal, great. So I have 3/2 x minus 3/2. So that means I'm going to start at negative 1/2. You can see that this was not a great straight line. Start at negative 1/2, and I'm going to go up 3, 1, 2, 3, and over 2. Okay? So keep in mind, look at this slope and look at this slope, okay? All right, here's the next thing. We reviewed this yesterday, but you may have been gone yesterday. If I pick out a random point, let's say along this line I pick out the point 6. 2 times 6 is 12. 12 divided by 3 is 4. 4 plus 1 is 5. So if I put in 6, I know I'm going to get a corresponding value of 5. So if 6, 5 is along the original function, who can tell me from yesterday, what does that become on the inverse function? You may be mumbling. Anybody else have an answer without mumbling? It becomes 5, 6. The x's in the function become the y's in the inverse. The y's in the original function become the x's in the inverse. Keep that in mind, okay? I think this is probably one of the most difficult problems for today. Look at number 11. Which of the statements is not always true? Okay, we know that, let's say one of the functions contains the origin, which is the ordered pair 0, 0. Well, when you switch them, what do you still have? 0, 0. Is that true? Okay, I know that's a true. I'm trying to find out which one is false. We're going to come back to this one. A function, let's look at this picture here. Can I draw a picture that never goes through? Can I draw a picture that never goes through the fourth quadrant? Sure I can, like this. Do you agree that original function never goes through the fourth quadrant? Yes or no? Okay. Now when I draw its inverse, and clearly you guys can see I'm not very good at drawing, do you agree that the inverse never goes through the second quadrant? So is it true that if a function has no points in the fourth, we can assume the inverse has no points in the second? Yes or no? That's true. Cross it out. We're trying to find out what is false. The slope of a linear function is less than 1. Let's look back here. The slope of a linear function is less than 1. This is true. 2/3 is less than 1. Then the next part says that the inverse will have a slope that's greater than 1. Do you agree 3/2 is greater than 1? That's true. So what's the only one that can be false? It would be the second one. If a function has 3 x-intercepts, then its inverse will always have 3 y-intercepts. Not always true. Please do second plus 7, 1, 2 when I just make a little better symbols here. Okay, biggest mistake I see students make here is when they plug this into their calculator, unless they put the number in back, your vertical shift, unless they put it first, your calculator often reads it as being part of the exponent. So to prevent that from happening, let's go second plus 7, 1, 2. Go up to y equals, and let's put the negative 2 in first. And then we'll follow it with a plus 5 raised to the negative x. When you're done, graph it, please. Okay, let's talk about the end behavior. As I go to the left, this function is headed up. As I go to the left, this function is headed up. How many of them say headed up? Going up. 1. There's our answer, but let's just keep looking here. As I go to the right, it's going towards negative 2. As I go to the right, it's going towards negative 2. If you would trace this, this keeps getting closer and closer to negative 2, but it will never actually touch it. Okay, go to the next one, please. We can do process of elimination. Please type in this formula, and we're just going to see, does this graph match this? If not, we'll look at the next 3 options. So let's type negative 2, and then in parentheses, 1/4 raised to the x. So some students in previous classes thought this ended here. This does not end here. This is a horizontal asymptote, and so it's getting closer and closer to the x-axis. It's hard to see that. So do you agree these two are exactly the same? Okay. We can keep moving on. Now, your test, which you have not received your grade back from, I would say about 25% of the students got this one right. So everybody is sitting close to somebody. You may not even know their name, but everybody has somebody that's within your group of 3. So if you have a group of 3, work as a group of 3. If you have a group of 2, work as a group of 2. Please do part A and part B. I am timing you. You have a minute and a half to do part A and part B. Ready, get set, begin. "45 seconds, keep working, then I will explain it." Okay, I'm going to draw a picture. I think that's the easiest way to understand this. It says that the minute hand on this particular watch, or the radius of the watch, is 1 unit. This is 1 unit. And this is often the most difficult part for students to understand. It says the minute hand, remember it's running fast, needs to be reset. And the minute hand of the watch subtends an arc of 16 pi over 3. That means it needs to be set back in an interior angle. It needs to be set back an interior angle of 16 pi over 3. That's the interior angle it needs to be set back. So the first part says, what is the length of the arc? What is this part that it needs to be set back? We've learned this is the formula for arc length. In this case, our radius is 1, and our interior angle is 16 pi over 3. When you multiply, you get a length on the outside of the watch that is subtended or needs to be pushed back of 16 pi over 3. That's the first part of the problem. The second part of the problem you have to also understand for the problem that will follow this, which is number 19. We know once around a clock is 60 minutes. For this particular clock or watch, we also know that the arc length is 2 pi over, the entire arc length of once around is 2 pi times a radius of 1. And we want to figure out how many minutes do we need to set this back when we know the arc length that needs to go back is 16 pi over 3. Grab your calculator, please. We're going to cross multiply. Let's start by typing in 16 pi divided by 3 and pressing enter. And then taking it times 60. So I've just cross multiplied, and instead of me writing that down, I'm going to represent this value just with a number sign. Now when I multiply the next two, 2 pi times 1 is 2 pi x. And if our goal is to solve for x, I need to eliminate 2 pi by dividing. So go divided by, put 2 pi in parentheses. This tells me how many minutes I need to turn it back. So I need to turn this back 160 minutes. Now I personally think it's easier to break this apart into hours. 60 minutes is 1 hour. Another 60 minutes, I'm up to 60, and 60 is 120. And 120 plus 40 is 160. So 120 plus 40 is 160. We're starting at 10:55 according to this problem. 10:55 is the time. And it should have said this, but let's say 10:55 a.m. Okay? So 10:55 a.m., let's go back 1 hour. 9:55 a.m., go back another hour. 8:55 a.m., now go back 40 minutes. 8:15 a.m. Turn to your partner, have at least one person explain it before we switch to a harder problem. Ready? You're going to have to understand this portion to do the next problem. Ready? Go. Okay, here we go. You have not done a problem like this. You have not done a problem like this. But it's very similar to the last problem, so pay close attention. We are told that the minute hand on a tower clock, okay? So you're thinking of large tower and there's a clock at the top. So I'll use my artistic ability. There we go, just like that. That's a tower.
Perfect.
There's Oma, also known as Omar at the bottom, okay? Large tower. Omar's down here. Okay, so we're told that the minute hand on this clock is 11.25 feet long. And we're told that we need to reset the clock, that right now the minute hand is traveling 84 minutes too far. So we need to set it back 84 minutes. That's all we know. So let's use the rational equations we know. We know that once around a clock is 60 minutes. And we know this particular clock, to go all the way around one time, is 2 pi r. And the r is 11.25. Now the problems we've done consistently in the last week and a half like this, we end up knowing the distance we have to go back when we find the actual time. In this problem, we know the time. We want to find the distance on the outside. It needs to go back. We know it's 84 minutes. Minutes with minutes, outside distance with outside distance. So we are going to solve here. Please type in, you don't have to use parentheses since there's no fractions. Type in 11.25 times 2 pi times 84 and get an answer. Okay, and we need to set that equal to 60, sorry, not 60 pi, to 60x. Well, when you isolate the x, you need to divide by 60. So let's divide this amount by 60. And this problem says rounding to the nearest foot, how far does it have to be set back? It would be 99 feet. Okay, next problem. Working with your partner on number 20. You have 30 seconds. Talk it out. Go. Counterclockwise is like this. It's going up this way. How many of you feel very confused about what this is asking? Hands up high. Okay, so here's my question for you. What is sine? Is that like an x or y value? A little bit louder. What is it? It's like a y value. Okay. So think of this in terms of the y-axis and the x-axis. We know we have to go in this direction. So tell me, your y values, okay? Think of you being on like a hot air balloon, okay? And all you want to ask yourself is, am I going upwards or am I going downwards? So you're in a hot air balloon and this is your balloon. Remember, I'm not very good at drawing. Okay, here we go. So up or down, what are you going right now? Okay, that means quadrant 1, the signs are going up. Okay, but you get all the way up here and now what do you start doing? You're in the hot air balloon. You're going down, okay? And are you still going down? But then when you get to this point, what do you start doing in the hot air balloon? You start going. So which quadrants have a sign value that is increasing? Quadrants 1 and 4. Okay, let me ask you another one. Make yourself a very simple circle. Let's do the exact same question, but now I want to change the word from sine to cosine. Sine to cosine. Talk to your partner. In which two quadrants, forget about these options, in which two quadrants does the cosine increase when you're moving counterclockwise? Counterclockwise is going like this. I think this is a tougher question for the majority of students. So cosines are like x's. So I'm only focused on this axis. Remember, the further you go to the right, the larger numbers you have, and the further you go to the left, the more negative they are, so the smaller numbers you have, okay? Does everybody understand that? So think in terms of x's. Okay, you're in a hot air balloon. All you want to go to is you want to go towards the large x's. Okay, so are you going towards the large x's? Nope. Are you still going towards the large x's? Nope. But once you hit here, do you see how you take a turn and now you start heading towards the large x's? So in which two quadrants are we increasing for our cosines? Quadrant 3 and 4.